Hi, this is Dr. Remenacker. In this video, we are going to look at modeling data via a process known as regression analysis. I will be using a TI-84. The processes that are the steps that we're going to look at will work for the TI-84 or the TI-83. If you have some other calculator, I would encourage you to go on YouTube and locate videos pertaining specifically to that video. The search criteria you would want to use would be something like regression analysis with and then enter in whatever the calculator is that you have, maybe a Casio FXG 100 or whatever the calculator might be, and you'll find hopefully videos there. All right, the idea of regression analysis is to take a set of data, like the set of data presented here on the left, and to convert it to an equation. Before we can do any analysis, calculus-wise, we need to get an equation. So what regression analysis actually does is it takes a set of data and converts it to an equation. In an earlier video, we looked at a series of different graphs and the type of equation that they represent. It's going to be very important for you to recognize the different shapes of graph and then be able to identify the type of function that best fits that type of graph. If you aren't sure what's going on with that, you'll need to go back and look at the review section 5 video. It lists about 9 different, well, 10, including the linear graph, 10 different shapes of graphs so that you'll become familiar with the graph and the type of function that's associated with that type of graph. Okay, I'm going to step you through this process. I would encourage you to get your calculator out and follow along step by step. If you find yourself getting behind or having troubles finding a button, pause this video. Okay, you do not want to get lost on this. The process involves a series of steps, but it's not hard. It's just a matter of learning the checklist of things that need to be taken care of to get this done. On the left side here, you can see that we're given some data, auto insurance premiums versus age. The first thing you're always going to want to do with your data is determine which data controls the other one. In this particular set of data, you would ask, does age control the auto premium, or does the auto premium control the age? Well, obviously, age controls the amount that you're going to be spending on your auto insurance. Okay. So what's going to wind up happening then is the thing that does the controlling is the X, and the set of data that is dictated by the other value is the Y. So in other words, the age of 18 dictates a premium of about $3,100. Okay. Now what we're going to do is we're going to turn to using the calculator. First thing you want to do is identify what is X and what is Y. Then you go to your calculator, which is on the right-hand side of your screen here. I'm going to turn this on. I don't want to do that, so I'll just turn this on. Okay, there's a series of steps. The first thing you want to do is to plot the data. Before you can determine what type of a function is going to fit the data, you have to know what the shape of the data is. In order to plot the data, the first thing I'm going to do is I'm going to come to Stat, which is in the second row, third button. Then notice I have 3 options across the top: Edit, Calculate, or Tests. We won't be using tests in this particular class, but we will be using Edit and Calculate. For right now, I want to edit, so I can either choose option 1 on the keyboard or just press Enter. Looks like I already have some data in, which is absolutely fine. The first thing I want to do is I want to clear my lists. Notice I have list 1, list 2, list 3. If you do not have list 1, list 2, okay, what you'll first need to do is come to Stat and then choose option number 5, okay, which is that, and press Enter. It'll then say it's done. You can come back to Stat, choose Edit, and you will have list 1 and list 2 restored. For most of what we're going to be doing, you're going to need list 1 and list 2. There might be a few cases where we'll need a list 3, which would be L3, but beyond that, we're just not going to use that much in this class. Okay, real important. How do I get these lists cleared out? Well, one option would be come down to delete and just press and get rid of it like that. That takes a lot of time, especially if you're on a quiz or a test. A second way to go about clearing a list is to using the up arrow. Notice L1 is now highlighted. Do not press delete. That will delete list 1, but press clear and then enter, and it's cleared list 1. Then you want to come over to list 2, so I'm going to do right arrow, up, and I want to clear list 2. Now that I have my lists cleared, I'm going to left arrow over to list 1. List 1 I will always use as my X value. List 2 I will always use as my Y value. So for my X value, I'm going to start entering in the data. 18, 22, 30, 40, 50, 60, and in this one we're just going to go up to 70. Okay, so we have these ages entered in. Then I'm going to move over to my list 2 with the right arrow. Notice on my screen across from 18 in list 2, I now want to put what the premium would be, $3,100. Okay, at 22 years of age, $1,850. At 30 years of age, $1,500. At 40 years of age, $1,450. At 50 years of age, $1,400. At 60 years of age, $1,350. And then at 70 years of age, it creeps up a little bit, back to $1,400. Check to make sure at this point that you have the same number of entries in list 1 as you have in list 2. If one of the lists is shorter or longer than the other one, you've missed a point somewhere or entered something in a couple of times. All right, so this is the first step, entering the data into the calculator. Ultimately, what we're going to want to do with this data is to plot it, to get a picture of what this data looks like. There are a series of things that need to be done to plot the data. The next thing I'm going to do is I'm going to come over here and I'm going to press y equals. I want to check two things. First, I want to make sure that my y1 through y7, and go down even further because there are a couple of them below y7, make sure that all of your y values are cleared out. If these are not cleared, it's going to be plotting equations that you really don't want to have plotted. Then with the up arrow, I'm going to move up and I want to make sure that plot 1 is highlighted. Notice right now plot 2 and plot 3 are not highlighted, but plot 1 is darkened or highlighted. If plot 1 is not highlighted, move the blinking cursor over to plot 1 and press enter. That will cause it to be highlighted. What that means is the calculator is looking to plot data based on what is in plot 1. Now we're going to have to set this up. So the next thing we're going to do is we're going to do second y equals, which is stat plot. You can see on my stat plot on the little dashboard here, it's set up to plot dots. The x value is list 1, the y value is list 2. It's going to use little plus signs or crosses for each data point, and it is turned on. If your stat plot 1 doesn't have any of those traits or is lacking some of those, press enter. It'll take you to plot 1. Move the cursor over to on, press enter. Then move it down to the type of data or the type of graph we want to do. We're going to want to do a scatter plot, which is this first type of data. Notice there are other types of data. Most of these are helpful in statistical applications. If you have one of the box and whisker or some other plot type highlighted, using the up and the left right arrows, get it to a scatter plot, press enter. The next thing you want to do is you want to go to your X list and make sure it reads list 1. To get list 1, look down the keyboard. See on the numeric key 1, in blue above that it says L1. To get it to read L1, you're going to press the blue key in the upper left and then press 1. It should read list 1. Move to list 2 or the Y list. If it's list 2, that's fantastic. You're ready to go. If it doesn't read list 2, notice at the bottom of the keyboard on the numeric key 2, in blue it says L2. To get the Y list to read L2, you press the blue key in the upper left and then the numeric key 2. Moving down to the type of mark you want to use for your plot, you can move the cursor left or right and choose whatever you want. Personally, I like the little crosses. It makes a large enough icon that I can actually see where it is relative to the graph that's going to be displayed later. And with the plus sign or the cross, it gives me kind of a crosshair so I can cite exactly how close is this data point to the actual function that we're trying out. Okay, so with all of that done, I've got my plot 1 set up. The next thing I need to do is to start preparing the calculator to display the data. What I want to do is I want to go to Window, which is on the top row of buttons. It's the second one. It says Window, so you just press Window. At present, my X value looks from a -2 to +10. Looking at my data over here on the left, my data goes up to 70. Now, my minimum is -2. I always like to create a graph where I can see to the left of the y-axis and below the x-axis. So I'm going to put this as something like -10. Press enter. Then for my maximum y value, the maximum I really need is 70. But I want to see a little bit beyond that so that the graph isn't jammed all the way up against the right corner of the screen. So I'm going to press 80. Now, to pick a scale size, this is how often do you want a little tick mark on the x-axis. If I was to do one every 2 values, that would give me about 45 tick marks, which would just really jam it up. It seems that about 10 tick marks is reasonable. To get 10 tick marks, what I do is I take the 80 minus the -10, which is 90. So I've got to go 90 steps total. Okay, divide that by 10 gives me 9. 9's kind of an odd number to count by. So what I'm going to do is I'm going to put in something very close to 9, but is an easy number to count by 10. Now I'm thinking about the y-axis. If I go from -5 up to 3,200, okay, that's going to be kind of a whole lot of area to cover. And the bottom area is not going to show much. From 0 to 1,400 or 0 to 1,350, it's not going to show much at all. What I'm going to do here is I'm going to move my axis view up some. I might start this at like 1,200. And I need to go up to at least 3,100, so I'll go up to 3,200. So there's a little space at the top as well. Now I'm going from 1,200 to 3,200, which is 2,000. Divide that by 10, that would be a step size of about 200. So I'm going to do 200 as my step size. And it takes me now to the resolution. Don't touch this. You don't need to fix anything else on the window. This is set the window. Don't mess with the resolutions in any way. The rest of it, just leave it on the default settings. All right, so what we've done thus far is we have set up our window so that it will control what the plot is going to do. And we have set up our Y value, making sure all the Y's are clear. We've set up our stat plot. We've turned it on. Okay, we've set up our X as list 1, our Y is list 2. Then we've also gone to stat and we've put the data in. So what I can do now is in this top row, I'm going to press graph and see what happens. Wow. Now what you want to do is you want to think about, okay, what kind of a function would fit this data? Well, it's not a clear line, clearly not a line, because a line would go like this. It's not a parabola because it would go down and come back up like that, more like a smile. This is where you really have to recognize your graphs. This is actually an exponential function. Okay. So what I want to do now is I want to ask the calculator to do a regression analysis to come up with a function that'll fit this data. I want it to be some type of an exponential function. To explain to the calculator what I want it to do and what type of function I want to use, I'm going to press stat. Now, at this point, I don't want to edit the data. I want to calculate. When I come over to calculate, the first two options are one variable and two variable stat. The third one is a median. We're never going to use these first three. Those are statistical applications. Option 4 is a linear regression. REG means regression. Quadratic regression, cubic, quartic. Now I'm going to come down the list and see what else it has to offer. Okay, after quartic, there's a linear regression. This is a plus bx, whereas the first option was ax plus b. This is a natural log. ln is natural log. Be careful when you're reading this. Number 10 is an exponential regression. Exponential regression. Yeah, that's what I'm looking for. So I'm going to press enter. On this, before it does the exponential regression, it's going to ask me where's list 1 or the X list. It's in list 1. The Y list is in list 2, so those look fine. Okay, I don't want to mess with this third one. Now, in this fourth one, it asks me where do I want to store the regression equation. What this is going to do is it's going to compute the equation and then it's going to paste it in to y1 equals or y2 or whichever variable you want it to equal. This saves you the time of having to write the equation down, go to y equals, and type it back in. The way you find and identify the location you want is you press variables. Variables is right here below the arrows. Now notice up at the top it gives you variables or y variables. We want to choose a y variable, so I'm going to use the right arrow, come over to y variables. I have a choice of format for my function. Do I want it to be a function, a parametric equation, or a polar equation? I definitely want it to be a function, so I'm going to choose option 1 or just press enter. Then I'm given the choice of, do I want to put this equation in y1, y2, y3? It may be the case if for some data, we're going to want to try several different equations. One of them you might want to put in y1, the next one in y2, and it allows you to then graph both equations to see which actually fits better. In this case, I want y1. I'm going to press enter. Notice it is now displayed that this result is going to be stored in y1. Come down to calculate using the down arrow, and now I'm going to press enter. It's thinking about it, and there we go. At this point, you can copy this down. Okay, this is a times b raised to the x power. Okay. I can also go to y equals, and notice it has put this equation in. and it's put it in with a great deal of accuracy. It's not just rounded off my decimals, one or two places. It's given us quite a few decimals of accuracy, and it'll do the same thing for the base as well. Okay, so now I have my function and I have my data both. If I press graph, it'll plot the data and it'll give me a graph. Huh, that doesn't look like such a great fit after all. Okay, so I'm going to keep that, but I'm going to go back to stat, move up to calculate, and I'm going to go down this list again using the down arrow, and I'm going to try another function. I'm going to try the power function this time. See if this fits better. I'm going to choose power regression, press enter. X is still list 1, Y is still list 2. I'm not going to worry about this frequency list. Here, I don't want to put this equation in y1 because I already have something in y1, so I'm going to do y variables, use the right arrow to move over to y variables. I want a function, and this time I'm going to choose y2 and press enter. So it's going to compute a second type of regression equation. It's going to store this in y2. I'll press enter for calculate. Okay, now if I go to y equals, you'll see that I now have two different types or two different equations entered. If I go to graph and ask it to graph, it'll plot the data. Here comes the first equation, which didn't fit real great. And hopefully soon, here comes the second equation. Between the two of these, it looks to me that the second equation fits better. Okay, so what I'm going to do now is this second equation is listed in y equals. I'll come down to y2, and I'm going to jot down what this equation looks like. What I have is y is equal to 9390.423. Okay, and remember, we're just going to use 3 digits when we report things on paper, so you don't have to write down all of these digits. Okay, and this is now going to be times x. See the x there? And on the x, we now have an exponent. See the exponent up here? It's going to be x to the negative 0.481, rounding it off to 3 digits. So what I'm going to wind up with is my set of data plotted, and the plot went something like this. And I'm going to have my function. I chose the second one, and the second one goes kind of like this. And when you draw these graphs by hand, I don't expect them to be perfect, okay? But I do expect it to pretty accurately represent what the data is doing. You will also want to, on your graph, include values like 18, 22, 30, 40, 50, 60, and you get the idea, 70. And along with that, include your Y scale. This Y scale is going to dip down to about 1350 here. And you got to get it up to 3100, so I'll put 3000 here, with 3100 just being above that. So my 1500 is at 30, so 1500 is going to be about here. And then the 1800 is going to be about there, so here's about 2000. Right around there would be 2500 and 3000. So you can kind of rough in what the graph's doing. Okay, I know my scale in the y direction's off a bit. Actually, both of them are off a bit. I was kind of quick about that. What you'll really want to do is you'll first want to put down your scale and then put the data on it. I did this backwards um, just for the sake of the video. Okay, we will take a look at a second set of data and work through that one in a second video. I would strongly encourage you to work through this video once with the video running and pressing all the buttons and things. Then I would encourage you to come back and do this without the video running, playing it only when you get stuck, because you're going to have to be able to do this stuff, okay, knowing what you're doing. Okay, when you get into a real world situation, you can't be looking up YouTube videos. Now, how do I do this again? And how do I do that? You get the idea, you'll look incompetent. And that's not how you want to look in front of your employer. Okay, there will be a second video. It will look at a second set of data. And that second set of data will give us a different shape graph than what we have here.